Good morning, good afternoon, everyone. It's Dan Scarborough here with Digital Infra Network. Very excited today. I'm joined by Rolf Jonsson, who's with Alfa Laval. He's responsible for the data center industry in Europe, and Cosimo Pecchioli, who is with Alfa Laval in North America, and he's also responsible for the data center industry. And we're talking about the challenges around heat reuse in the data center industry. So thank you very much for joining us, gentlemen.
Thank you for having us. Thank you.
So ideally, if we could just kick off, and I don't mind who answers this, but if you could just give kind of a brief introduction to Alfa Laval from a data center perspective.
Yeah, for those who are not so familiar with Alfa Laval, we are a Swedish company, world leader within the technology areas of heat transfer, separation, and fluid handling. We are a 4 billion euro company with close to 18,000 employees. And we have several major production units, and we are well represented with sales and service all over the world. We offer solutions and products that enable energy efficient cooling and heat reuse for all sizes of data centers. But we also do our homework, and that's to be carbon neutral by 2030. It's a question of credibility, for instance, to be here talking about heat reuse and carbon emissions.
That's great. Thank you very much. So today we've got a talk that we're talking about data center heat reuse, challenges, solutions, and opportunities, and excited to get your take on it. So maybe if we could just start, Cosimo, if we can start with you and maybe talk about why is heat reuse becoming so important from an industry perspective?
Well, there's a couple of main reasons. There's a sustainability reason that now either governments or single companies, they all have their sustainability goals that they want to achieve in 2030, like Alfa Laval, 2040, 2050. You hear these goals every day: carbon neutral, carbon positive. And if data center companies want to achieve those goals in these 10-ish years, heat reuse is going to be part of this plan, undoubtedly. So this is from let's say a market and sustainability point of view, but there's a technical reason, and that is essentially liquid cooling. Heat reuse has been around for a while, and even when you have liquid cooled servers and so liquid cooled white rooms, even when you have air cooled servers and even when you have air cooled server rooms, you have heat reuse opportunities, but those are a little more limited and are really strongly dependent on the climate that where you are, so or the region of the world. If you are in Norway, it's something, or in Sweden. If you are in Phoenix, Arizona, or in Singapore, you have a little less opportunities. Liquid cooling kind of changed that a little, because instead of having 27, 28 degrees air that you want to reuse, now you have 45, 50, up to 65 Celsius heat in a liquid, which normally is water. And that is a game changer for technical reasons that we will see probably later.
Yeah, okay. So let's maybe talk about the timing of this stuff. And, you know, Ralph, I know you're based in Sweden.
I am.
And Sweden's been very advanced in terms of this type of application because of your kind of district heating systems. So yeah. Why is it, are you seeing it's changing significantly from a timing perspective? Is it much easier to do heat reuse now than it has been previously? And why are we seeing that the timing is now?
The timing is now. It's actually the technology that is available, we could say, right now. So that's one thing. And the other thing is actually, if we go historically to how to recover or reuse the heat. Before we have had rather early generations of district energy nets, and those were providing from the beginning steam, so high pressure, high temperature. Now we can see 4, and generation number 5 is on its way, and the temperature is going down in the district energy net or the district heating net, which means that we are closing up to the data center that is increasing the temperature. So in fact, we close the gap in a very good way if we refer this to what happens in Europe and in Northern Europe, especially in the Nordic countries. So it means the possibility to use or reuse the heat increases without adding more electricity using heat pumps. So it could be directly used.
So that's really interesting. So what you're saying to me is that the district heating systems are becoming more efficient, so they can heat with lower temperatures. And then data centers are becoming again more efficient, and they're giving a higher output because of liquid cooling of temperatures. So that delta between what the district heating system needs and what the data center provides is becoming a lot lower than it has been historically. Is that correct?
That's correct. So they are meeting up, and also we shouldn't get stuck into the district heating or district energy side. In the latest, as I mentioned, generation 4 or 5, we can go with temperatures in the district heating net with 15 degrees up to 45 degrees, for instance, which means if we look into what happens in Europe, a lot of heat pumps will be installed if we look into the plants. And it means that we might be able to use reuse the heat from low temperature. It could be data centers, but it could be other heat sources, and using a heat pump lifting it up instead of using air from outside to increase the efficiency and reduce the electricity that's needed to be added.
Yes, I was going to ask you, in terms of the heat reuse opportunities that are out there, other than district heating, which we think we've covered, what other applications are you seeing both in North America, Cosimo, and in Europe, Ralph? Maybe we'll start with Cosimo for these types of this type of heat output from data centers.
Yeah, that is an excellent question, because actually I wanted to interject myself. So district heating is definitely the go-to place when you talk about when you think about heat reuse for data center. But even though it's a fantastic opportunity based on your region, it's not the only one. In some cases, is not even the best one. District heating, as Ralph was saying, is evolving significantly, and that makes that more interesting for data center, but has a big challenge that it's kind of unsolvable, that it's highly seasonal. So of course you need heat depending where you are in the world, but you need heat 6-7 months a year. And of course, we use the heat from the data center for 7 months a year. It's better than nothing. It's better than 1 month a year. So absolutely, it's a fantastic opportunity. Nevertheless, there are other more industrial opportunities where you actually have a chance to transfer that heat 24/7, 365, and those are of course interesting because at this point it's kind of a symbiosis between the data center and these heat reuse opportunities. And we are talking about any kind of preheating for industrial applications. It could be like ethanol plant production, where they need to actually ferment and rise the temperatures. It could be a wastewater treatment plant. It could be even applications that are kind of related to like district heating, like large hospitals or any kind of campuses, or where you need actually hot water essentially year round. So there are a number: biomass dry cooling, water distillation, which means water desalination if you are close to the sea. There are a large number of opportunities, all depends essentially what kind of temperature you have out of your data center and how much do you have and where you're located physically. If you are in the middle of the desert or you are in an urban environment, do you have 1 megawatt at 50 Celsius or you have 150 megawatt at 32 Celsius?
And this has got a value, right? So it's also got a value not only from a sustainability perspective, but from an energy and a cost perspective. Ralph, are you seeing the same types of applications in Europe or other regions, or are there any differentials?
Yeah, we see, of course, we can see these opportunities as well. We have this energy crisis arising, and we have a winter in front of us, and we know that we need to change from a lot of gas heated homes all over Europe, and we really need to use the opportunity for waste heat or reuse heat from other sources as much as possible and distribute it. That's really important. We see the same areas, of course, but we also find other areas of use. We have seen fish farms and lobster farming, also using it to dry biomass and produce pellets, for instance, during the summertime. And in the wintertime, this pellets is used to warm up homes, also as a biofuel for district energy nets.
So let's just let's talk about some of the challenges, right? So how easy is this to do? Why are we not already doing this? Why is this not more kind of widely done, other than the fact that it's not it hasn't been historically a legal requirement? What are some of the main challenges of heat reuse?
Should you start for me? Do you start, Cosimo?
Whatever.
Yeah, Cosimo, let's start with Cosimo.
Yep.
So the biggest challenge that we face right now is actually put together supply and demand. Heat for data centers right now is a liability, is not an asset. Actually, they use energy to get rid of the heat with the cooling systems that actually we provide. And data centers in the list of priorities that a company goes through to determine the location of a data center, heat reuse opportunities is not even present. So as we were saying before, if you have a large hyperscale data center in the middle of the desert, you don't have many heat reuse opportunities because you are isolated from all the rest of the world. So again, the biggest challenge that we face right now, it's really put together supply and demand. If you have very different entities, IT companies combined with food production companies, like Ralph was talking before, IT companies paired together with a wastewater treatment plant. Those are very different companies that they don't kind of talk to each other very often. So as I kind of joke, but I used to say that we need a Tinder for heat reuse. We need a matchmaking platform where you put together these companies. And then we need a legislative environment that makes this easier. It could be through regulation, so kind of a stick approach, or could be through incentives and subsidies, so a kind of a carrot approach. But that would greatly facilitate these.
I like the Tinder for heat reuse. I think that's definitely a good plan. Ralph, have you seen any other challenges from a technical perspective?
Yeah. In fact, it's not really the technical issues behind it. It's more building codes, regulations, and ownership is also a hot topic. I mean, who's responsible for the heat produced in a data center? Is it the data center itself, or is it someone else's problem? if we take this and look at it from a European, a North European, using it in district heating, we are very lucky in that perspective, because we have energy companies providing electricity and district heating and district cooling, and that helps out because they can help the data center to bridge, to take care of the heat, and also guarantee the cooling, of course, on the other hand. So
Yeah, no,
but I mean, the problem, it takes a crisis, I think, and we have a crisis to help each other. So I think we will come along, and because we've done this before. I mean, we have systems for wastewater, we have tap water, we have gas network, we have electricity network, we have fiber network, and we have been able to distribute everything through the net. And I think it's possible even for the heat reuse, and it's time for it now, because this is the only way to meet the net zero commitments of 2050 that's arising.
yeah, I think
Let me build on that. Let me build on that 1 second. Let me reinforce that. From the technical point of view, is not a challenge. We have been doing this for hundreds of years. Move the heat from one place to another, increase the temperature, handle the heat. That is not a problem. The challenge is really to put together a continuous, absolutely reliable source of heat, like is the data center, that it's a fantastic heat plant with something else, and there's plenty of opportunities that they can use that heat.
Oh no, I get what you're saying, Cosmo. I think the challenge is the distance over which heat can travel, right? So it's about proximity. So you have
to be planned. It really needs to be planned.
And you know, if it's a bit like brand new houses, if you could get each and every brand new house to become zero carbon, that's not going to deal with the 99% of all the houses that are already built, right? So how do you provide a retrofittable solution, or a solution from a heat reuse perspective that allows the existing assets that are out there that are, as someone put it the other day, dumping waste heat, which is data centers' dirty little secret in a way? How do you deal with that issue? How do you create a portable solution for this? Or how do you make it so that it's not just dealing with net new assets, it's dealing with the existing assets? That's the biggest challenge as far as I can see.
And the amount of energy that is used currently to get rid of that heat, which could be an asset, it's phenomenal. 100 megawatt, which admittedly is a very large data center, but 100 megawatt the data center, which corresponds about 26,000 homes, employs about 40% of that energy, so 40 megawatt, just to cool down the data center.
Yeah, I mean, I think there are practicalities, and I understand the difference between, you know, air cooling and liquid cooling, and that kind of movement in that direction, which I don't think one's going to replace the other, but there's definitely going to be a larger amount of liquid cooling deployments given the changes in the chipsets that are being developed. But even then, if you look at the way the cooling infrastructure, you know, expels the heat that it removes from the room, it's still ejecting heat, right? Whether it's an air-cooled or liquid, it doesn't really make any odds. The heat is still being ejected into the atmosphere. So what are the opportunities? I mean, how easy is it to retrofit a liquid? How easy is it to retrofit a heat reuse application? It's not, is it? It's pretty challenging, I would imagine, to find a heat reuse application that is retrofittable or is something that you can bring to a data center, unless you're building vertical farms next door, or you're, you know, providing some other industrial application that on that site of that asset that would be able to compensate for the heat. You know, we've got a bit of a challenge ahead of us to compensate or to introduce heat reuse into some of these existing footprint. Ralph?
Yeah.
Yeah.
I mean, it's all about the neighbors in that case. As you said, we can't provide liquids or transport the energy. It's so huge amount of energy, so we can't put it into our pockets. We need to transport it in piping systems. So that's for sure. It's really tricky for us to solve it. But I'm sure that this crisis, energy crisis, we will be even more creative to try to cooperate and find solutions to be able to reach that target, because we have to.
Well, this is one of the things I was going to say. I mean, I'm assuming that as an organization, you are open to having these conversations with operators, right? And seeing how, they could, adapt their facilities or work in unique ways, because it's a lateral thought process that you need to adopt. So the more that, the operators are talking with companies like yourselves to understand the applications for particular sites and what can be used on a site-by-site level, the closer we're going to get to dealing with some of these assets that are not at first glance obvious, reusers of heat. Would you say that was a fair assumption?
Yeah, I think so. Yeah. What do you say, Cosimo? You agree?
So I'm not sure I actually fully understand the question. Are you asking how difficult it is technically to retrofit?
No, I'm talking about a business relationship between companies like Alfa Laval, who are specialists in this area, and operators of data centers who are not specialists in this area. And by engaging in conversations between the two sides, you can look at where a solution is possible and where a solution is not possible. And if there is a solution that isn't technically possible now, or might need some thought process around it, then it's about working together, isn't it? It's about collaborating as an industry to be able to increase the amount of heat that's currently captured and reused from these assets. And that's going to take cooperation between the various different stakeholders.
Yeah, no,
yes.
I don't think that is a challenge at all. Actually, to be honest, because we were already in contact with those companies, because we have been working with those companies for many years to cool down their data centers. So it's kind of a natural evolution of our relationship. Instead of getting rid of that heat, let's work together to reuse that heat. And large IT companies and large companies nowadays are actually proactively reaching out to us to see what can be done. So it's not that we have to sell them anything. Actually, we are working.
I get that, but that's reflected in the percentage. So what would you say as a percentage of data centers that you're engaged with? What percentage of heat is currently being reused?
In the US, it's probably, it would be hard to measure. It's probably nothing.
Yeah, so it's a very small percentage currently, right? So even though it isn't a challenge to have the engagement isn't leading to a change in behavior, right? So how do we get to a point where we've got and that's part of the challenge with getting to zero carbon, isn't it? If we're going to get to zero carbon, we have to do things differently to how we've done them previously. And that takes a different type of engagement. It takes a much more proactive partnership, plan. If you look at, for instance, the design of data centers, right? These data centers have been designed in Europe to deal with up to 35 degrees ambient temperature. We're now reaching 40 degrees. We're now reaching over 40 degrees in Europe. And, you're hearing stories of people with hose pipes on top of data centers cooling adiabatic cooling units on multiple billion-dollar assets, right? So that wasn't foresawn at the point that data center was designed, and the challenges are only going to become more extreme. And so changing how we work together and being, much more aggressive in our targets and aggressive in our approach to kind of avoid wasting energy, which is ultimately what we're doing, is going to take a different type of cooperation. That's kind of what I'm alluding to.
No, I mean, absolutely. But we have to remember that even though the first examples of heat reuse go back about 10 years, like in the US would be the NREL in Colorado, where they started reusing their heat for their offices. But at the larger scale, we are at the infancy. I remember reading about the infancy of the oil and gas industry, where they wanted to produce gas for illumination, and gasoline was a byproduct that was dumped into the sea. We are kind in the same conjunction now. So we are realizing that what was used to be a liability, it could be actually be an asset. But we need to create a structure. We need to create our gas stations. We need to create our cars. We need to create the infrastructure to make that asset usable.
Yeah, and I get that. And unfortunately, we don't have the time and the ability to wait for that to happen in the natural course of human evolution that we have done historically. So I'm hoping that there's a way that we can speed that process up.
Well, I mean, as we say, never let a good crisis go to waste, right? So yeah. This energy crisis could be really like the nudge that moves into that direction.
Oh, I 100% agree with you. If you look at the price per kilowatt increase, you know, you either have to reduce the amount of power consumed, or you have to pay a significant amount more. So I think there's a lot more motivation out there from a financial perspective to make the changes. But listen, gentlemen, thank you very much for the conversation. I've really enjoyed it, and you know, please, anyone who's interested in engaging with Alfa Laval, you know, go to their website, go to their partner page, and let's continue the discussion and see how we can get more heat reused.
Again, thank you for having us.
Thank you.
Thanks very much.